So I want to explain something called the complex number system and how all these different types of numbers fit in together. So here's a diagram of how they might relate to each other. We're going to start here with the whole numbers in the middle. Sometimes these are called the counting numbers. These are the numbers that you learned in elementary school. They're just wholes. There's no parts to anything. So things like 0, 1, 2, 3, etc. There's no fractions, there's no decimals, they're all positive numbers. It's the things that you would count by. Earlier this year, and maybe a little bit last year, we expanded your knowledge to include integers. So again, there's still no fraction or decimal, but we have -3, -2, -1. 0, of course, is in there. And then going back up into the counting numbers. Okay, they go in both directions for the integers. So we've added on another side to the whole numbers. Whole numbers are integers, but not every integer is a whole number. For example, -3, it's only an integer. Then we talk about rational numbers. These are things that can be written like a fraction. Okay, you'll see the word ratio in there. That's how you remember that they can be written like a fraction. So all of the whole numbers, 1, 40, 923, are rational numbers because you can put them over 1. The integers are also rational numbers. -2, -723 can all be written over 1 or written as a fraction. But we also include in this fractions and decimals. So for example, you could have 1/2, -0.2, 5 2/8. Anything that can be written as a fraction, or in this case, a decimal. Then we get into real numbers, and these are so popular when you get into higher levels of math, they have their own symbol. It's like a capital R with 2 lines instead of 1. That's the shortcut for real numbers. Real numbers, for the most part, are anything that you know how to deal with. Okay, fractions, decimals, positive, negatives, even numbers that go on repeat or that repeat without end. And we didn't talk about those yet. So real numbers are pretty much anything that you could possibly deal with. Now, out here, this irrational bubble. If these are rational, what does the prefix IR mean? Ir means not. So these are things that cannot be written as fractions. You will talk a little bit about these in middle school, but most of the time these are dealt with in high school. Things like pi is an irrational number when we talk about circles and Pi Day in March. Numbers that repeat but don't end. Most of the numbers that repeat here, most of the numbers that we deal with that repeat will be in the rational numbers. They can be written like fractions, like 0.7 repeating would be 7/9. These are other ones that really don't have a pattern. And then we talk about the imaginary numbers. So most of your studies will be whole numbers, integers, rational numbers are a big one this year. And then we start talking a little bit about real numbers. We do very little over here in middle school. And this one you won't even see until the end of high school. Now, imaginary numbers does not mean that they don't exist. They do exist. But it's a special situation that we kind of had to invent a symbol. And I'll give you a really fast crash course on this. I is actually a number. I know, mind blown in certain situations in math. So I'm going to flip this over for a second. So think about square root, okay? You know that a square root, or maybe you don't know and you're about to find out, undoes a square, right? So if I have 2 to the second power, we say that's 2 squared. This square root undoes that square, so the square root of 4 is 2. Now, you've just learned about positive and negative numbers. There's actually 2 answers for that. You can have positive 2 times positive 2 to get 4, or I can have negative 2 times negative 2 to get positive 4. So I can have 2 squared, or I can have negative 2 squared, and they'll both give me 4. But what happens when I have a negative number underneath that radical sign? The square root sign is called the radical. What times itself could possibly give me -4? Could it be 2 times -2? Well, yeah, that'll give me a -4, but they're not the same number, so that won't work. Could I do 2 times 2? That won't give me -4. What about -2 times -2? Still doesn't give me -4. There's nothing times itself that will give me a negative number. So what they had to do was take out that negative, the square root of a negative. This answer is actually 2i. It's an imaginary number. That is my super, super duper fast crash course on imaginary numbers. Just know it's coming, and it's fun because it's unique.